Hey everyone, and welcome to this explainer. Okay, today we are doing a deep dive, a really hyper-focused look at question 12 straight from the Edexcel's GCSE Maths higher tier paper. We're going to completely master this exact coordinate geometry challenge, and we're going to do it using the clearest, most structured visual map possible.
Just to set the scene really quickly, this challenge is pulled right from paper 2. That's the calculator paper from Friday, November 10th, 2023. Now, since we've got our calculators handy, we are absolutely not going to get bogged down in mental math. We'll let the machine do the heavy arithmetic lifting so we can keep our brain power completely dialed in on the actual geometry logic.
All right, let's look at the beast itself. Question 12 reads, M is the midpoint of AB, N is the midpoint of BC. Work out the distance between M and N. Give your answer correct to one decimal place. I mean, on the surface, it's just 4 short sentences, right? But don't let that fool you. There is a very specific sequence of mathematical actions we need to take here to extract those 3 precious marks. Oh, and keep an eye on that last sentence, the prompt around to one decimal place. That is going to be absolutely crucial right at the finish line.
Okay, let's dive right into this. Honestly, to crush this question, you only really need a super straightforward 2-step mental map in your head. Step 1, we calculate the exact coordinates for the 2 midpoints, M and N. Step 2, we take those brand new coordinates and we apply Pythagoras' theorem to find the distance between them. Seriously, that's the whole shebang. 2 logical steps that create a direct bridge to a perfect score. Let's break down exactly what that looks like on the page.
So moving right into phase 1, calculating the midpoints for that first P1 mark.
Let's check out the exact coordinate arithmetic we need to secure this first mark. You probably know the drill for finding a midpoint, right? You just find the average of your x coordinates and the average of your y coordinates. So looking at the official workings for midpoint M, we add our coordinates and divide by 2. 7 minus 3 over 2 gives us an x coordinate of 2. And then 13 plus 21 over 2 gives us a y coordinate of 17. So M sits nicely at 217. Then we literally just rinse and repeat for N. 15 minus 3 over 2 gets us 6. 23 plus 21 over 2 is 22. So N is down at 622. Just getting these exact calculations written down on your paper guarantees you that first P1 mark. Now here is a fantastic little insider secret straight from the official Edexcel rules for this question. It explicitly says, condone missing brackets on coordinates. Honestly, this is a lifesaver. It means if you're stressing during the exam, rushing against the clock, and you accidentally write down your coordinates as just numbers separated by a comma without those outside parentheses, you're perfectly fine. You will not be penalized. They are looking to see if you understand the actual mathematical process here, not just checking your formatting perfectly at this stage. All right, on to phase 2, applying Pythagoras for that second P1 mark. Okay, so we've got our midpoints now. M is right there at 217, and N is up at 622. The next job? Finding the actual distance between them, and this brilliantly illustrates exactly the math we need next. We just take the difference between our x-coordinates, square it, and then add it to the difference between our y-coordinates squared. Let's do it. 6 minus 2 is 4, and 4 squared gives us 16. 22 minus 17 is 5, and 5 squared is 25. Add 16 and 25 together, and we get 41. Now listen up, because this is key. Simply showing this exact substitution, plugging those newly found midpoint values into the distance formula to get 41, is what absolutely locks in that second P1 mark. You don't even have to waste time writing out the general formula first. The substitution itself perfectly proves you know exactly what you're doing. Moving to the final stage, the result, and securing that final A1 mark. We are literally at the finish line now. We figured out the square of our distance is 41, right? So we simply punch the square root of 41 into our calculator. That pops out a long decimal that starts with 6.4031 and so on. But remember that crucial detail from the prompt? The question explicitly asked for one decimal place. Now, according to the mark scheme, the acceptable final answers are actually anything in the range of 6.4 to 6.41. That means writing 6.4, 6.40, or even 6.403 are all technically valid pathways to full credit. But wait, there is another absolute game changer written right into the rules. It says, if an answer is given in the range, in working, and then rounded incorrectly, award full marks. Basically, if you clearly write 6.403 down in your working space, but then you totally panic and write 6.5 on the final answer line, they'll still give you the full 3 marks. How great is that safety net?
But of course, ultimately, the absolute gold standard, perfectly correct final answer that satisfies that one decimal place instruction is simply 6.4. Nailing this clean, incredibly satisfying final number means you've successfully navigated this entire logical puzzle exactly the way the examiners intended.
So, I want to leave you with a thought as we wrap up this explainer. Maths isn't just about crunching random, disconnected numbers. It's really about recognizing these structured pathways. Think about it. If you take the time to memorize this exact, totally predictable two-step logic, midpoints first, then Pythagoras second, how many other coordinate geometry questions could you instantly unlock on your next paper? It's like a master key. Lock this visual map in your head, and next time you open an exam paper, tackle it with total confidence. Thanks so much for learning with me today, and I'll catch you next time.